This is a review for test 6. Alright, in this test you will need to identify the 3 major types of reactions, and those are formation, also known as synthesis or composition, and then decomposition, and complete combustion. Now you'll have to identify a reaction as one of these 3s or as something other than that, none of these. So let's write a reaction. Let's say that hydrochloric acid changes into hydrogen gas plus chlorine gas. Okay, to balance it, I'll write a 2 here, and then that'll be balanced. This reaction is a decomposition reaction because it takes a reactant, that's one thing, and breaks it into smaller, simpler substances. So decomposition. Now formation or composition would be the opposite of this. You would have several things coming together to make one thing. Okay, so these are just opposites of each other. Now, decomposition doesn't have to be single elements. It can decompose into just simpler substances, so don't let it fool you. Decomposition is when you start with one reactant. Okay, now complete combustion is a little bit more difficult. Let me get a different page and show you that. Okay, a complete combustion reaction starts with a carbon-hydrogen reactant. So let's say C2H6. Okay, and then it always, when you see complete combustion, you need to think of these 3 things. You're going to add oxygen gas, you're going to get out carbon dioxide, and water. Always. Complete combustion. You should just think in your head, oxygen gas plus carbon dioxide and water. Okay, now that I've written the reaction, I need to balance it. So we'll put a 2 here. And then I have 3 here, so I can get 6 hydrogens on both sides. Now let's check my oxygen. I have 4 plus 3 more is 7, and 7's an odd number. This would work if I had 3.5 here, but we can't have a half as a balancing number. So I'm going to go through and double all of these yellow numbers, and that'll be my new balancing numbers. And let's check and make sure they're right. On this side I have 4 carbons and 12 hydrogens and 14 oxygens. On this side I have 4 carbons, 8 oxygens, plus 6 more oxygens, which is 14 oxygens. And then I have 12 hydrogens. So it is balanced. Okay, and this is called a complete combustion reaction. So sometimes you can add oxygen to a reactant and you'll get a product, but it won't be carbon dioxide and water. So complete combustion is always adding oxygen and only producing carbon dioxide and water. Now, you will have to write formation, decompositions, and complete combustion reactions, not just identify them. So let's do a few more practice problems. So if I was to say, write the formula for the formation of H2SO4, I would know that formation ends with H2SO4. So what does it need to start with? It needs to start with each of these elements, and I write them like this. And then I think, are any of these homonuclear diatomics? You know there are 7 plus 1 homonuclear diatomics. And it starts with element number 7, which is nitrogen. And then it goes to oxygen, fluorine, and then it starts going down to chlorine, bromine, iodine, and astatine probably. And then the plus 1 is hydrogen gas. So if we have these 8 elements, we are always going to need a 2 when they are by themselves. So hydrogen is a homonuclear diatomic, and so is oxygen. Notice that sulfur isn't, so I'm going to leave that as a plain element. Now I need to balance it. I have 2 oxygens on this side and 4 on that side. So I'm going to put a big 2 here. And that is balanced. So that's how you write a formation reaction. A decomposition reaction, again, would be exactly the same, only you're starting with the one reactant and breaking it into 2 parts. And a complete combustion, again, you start with something that can burn. Let's say CH2O has to be only carbon, hydrogen, oxygen, or oxygen. It can just be carbon-hydrogen products. Now to burn anything, you have to add oxygen gas, and you only get out carbon dioxide and water. To balance it, let's see, I have 3 oxygens and 3 oxygens, 2 hydrogens, 1 carbon. This is balanced already. So this is a complete combustion reaction that I've written. Now you'll also need to be able to write the molar mass. So let's look at HCl. The molar mass of HCl is, looking at the periodic table, hydrogen is 1.0, chlorine is 35.5, so the molar mass of HCl would be 36.5 grams per mole. Let's do something that might be a little harder. NH4 3 3 O NH, okay, put a 2 here, NH420. So that means I have 2 NH4s, so that means I also have 2 N's, 8 H's, and 1 oxygen. So nitrogen is 14.0. Multiply that number by 2. Hydrogen again is 1.0, and I'm going to multiply that by 8. Oxygen is 16.0. There's only one of those. So 28 plus 8 plus 16, 42.0 grams per mole. Okay, so that's how you get molar mass. You just add up the masses from the periodic table for each of your atoms that's represented. You'll need to take a amount of moles. Let's say I have 18 moles of water. How many grams do I have? So moles to grams. Our clue word is MGM. Moles to gram, I need to multiply. So I'm going to add up water's weight. 2 hydrogens and 1 oxygen. Oxygen weighs 16, hydrogens weigh 1. So I'm going to multiply the gram number by the grams per mole. And this is not the gram number, this is the moles, right? Get it from here. And 18 times 18, whatever that is, because I don't have a calculator with me, that would be the amount of grams I would have of water. Does that make sense? If you're changing from moles, if they gave you the moles in the problem and they want to know the grams, then you multiply by the molar mass. To go backwards, if we know the grams of something and we want to know how many moles there are in that sample, then we need to divide by the molar mass. So if I had 18 grams of water and I want to know how many moles there were, I need to take the grams and divide by the grams per mole. And then I would get 1 mole there. Okay, so grams to moles you divide by the molar mass. Now before you forget, what does moles mean? Moles is a counting unit that we use for chemistry, and 1 mole of anything is 6.02 times 10 to the 23rd atoms. You need to have that number memorized. So if we were talking about 1 mole, we have that many atoms or molecules. Okay, you're going to be asked something about 2 elements. Let's say oxygen and carbon. And if I have 4 grams of oxygen or 6 grams of carbon, which one has more atoms in there? Well, before you can answer that, you have to change to moles. So grams to moles, I'm going to divide. So 4 divided by 16, which is oxygen's weight, is 0.25 moles. Carbon is 12, so 6 divided by 12 grams per mole equals 0.5 moles. So 0.5 is bigger than 0.25. So carbon, the 6 grams of carbon has more atoms. Because remember, a mole is just a counting number for atoms. All right, make sure you also know about carbon monoxide, and that if you don't have enough oxygen when you burn something, you can produce two things. You can produce soot, and then you can also produce carbon monoxide. Soot is inconvenient because it's pretty hard to clean off, but carbon monoxide is even worse because it can kill you. You can get carbon monoxide poisoning. So this is why we need to make sure that we're careful not to burn barbecue grills inside or in an enclosed area, so we're not producing carbon monoxide. With the soot, if you are burning a candle and you let the wick get a little bit too long, it'll make that sooty black on that inside of the candle glass, and it's pretty hard to clean up. And that's because the fire flame is too high with that long wick, and they tell you to trim the wick off a bit, and then it'll stay a lot cleaner. We don't really need to worry about carbon monoxide too much with candles, because the flame isn't enough to really, or it's not producing enough carbon monoxide to actually hurt us. But still, it's probably not a good idea. So keep your candle wicks cleaned, or keep your candle wicks a little short, and you won't get that soot on the outside. Okay, and the last topic that you'll be tested over is how to read the balancing number as the moles. So let's write our formation water reaction, just because it's pretty easy to write. And let's write the mole story, or how many moles we need. So 2 moles of hydrogen gas react with 1 mole of oxygen gas to get me 2 moles of water. Now I can take any of these up or down in proportion. So if I want 1 mole of water produced, how many moles of oxygen do I need? Well, going from 2 moles of hydrogen to only, or water, to only 1 mole of water, I'm halving it. So for the oxygen, the balancing number is 1. So if I half that, it is 0.5 moles. Now, we can't have a fraction as a balancing number, but I can have it in this mole story, because 0.5 moles is not a half of a molecule or an atom, it's half of a bucket, or way more than a bucket, so it's half of a lot of them. So I can have it that way if I want to. Okay, and a quick one, if I want to use, let's say, 6 moles of hydrogen gas, how many moles of water will I produce? Well, water and hydrogen gas are the same number. So if I increase this by 3, I'm going to have to increase the water moles by 3. So I will also need 6 moles of water. Okay, there's a test review sheet that you can fill out, and the substitute will have the answers for. So I will see you when I get back and do well on this test.